Our lecture for today is the diffraction of laser from the single slit. The word laser is an acronym for light amplification by stimulated emission of radiation. Laser light today cover a wide range of wavelengths from about 150 nanometers to about 12,000 nanometers, which includes the visible range of the electromagnetic spectrum. The invention of laser source was possible ever since Einstein in 1917 showed theoretically that the process of stimulated emission of radiation must exist to balance the absorption and spontaneous emission of radiation processes. In 1950, a group of scientists at Columbia University operated a microwave device that amplified radiation by stimulated emission process. This device was termed MASER, an acronym for microwave amplification by stimulated emission of radiation. In 1960, Th. Mayman produced a laser beam from ruby crystal. Ruby is an aluminum oxide crystal in which some of the aluminum atoms have been replaced with chromium atoms, as shown in this photo. For a ruby laser, a crystal of ruby is formed into a cylinder. A fully reflecting mirror is placed on one end and a partially reflecting mirror on the other. A high-intensity lamp is spiraled around the ruby cylinder to provide a flash of white light that triggers the laser action. The green and blue wavelengths in the flash excite electrons in the chromium atoms to a higher energy level. Upon returning to their normal state, the electrons emit their characteristic ruby red light. The mirrors reflect some of this light back and forth inside the ruby crystal, stimulating other excited chromium atoms to produce more red light, until the light pulse builds up to high power and drains the energy stored in the crystal. Basic principles of laser operation. For the construction of laser system, 3 basic requirements, which should satisfy certain conditions, must be provided. These are: 1. An active medium. It represents the collection of atoms, molecules, or ions that emit radiation in the optical part of the electromagnetic spectrum. The active medium of a laser might be in gas, liquid, or solid form, also a semiconductor. 2. Pumping energy. The energy needed for the excitation procedure in the laser medium. 3. Optical resonator. The means of the optical feedback in the laser system. This is needed for laser oscillations to provide a highly collimated monochromatic beam that makes the stimulated emission in the laser medium so useful. Spontaneous emission. An excited atom cannot continue having the excess of energy, which it had absorbed, for a long time. Usually it tends to return decays to a lower energy state by releasing energy. This process occurs spontaneously and randomly. Stimulated emission. The excited atom is forced by the incident wave to release photons in the same direction and frequency of incident energy. Radiation emitted by stimulated emission process is coherent and directional. Properties of laser light. Laser light differs from any other source of light. It represents the highest quality light source so far. The particular properties that are responsible for this high-quality product are: 1. Monochromaticity. The electromagnetic radiation is single frequency, single wavelength, or single color, 100% monochromatic radiation. 2. Coherence. This property is closely related to the wave nature of the light, i.e. the amplitude and the phase. The light from laser source is considered as a beam with frequency about 10 to power of 14 Hz. It means have wavelength with few micrometer. These beams have the coherence property when they have approximate values of frequency and wavelengths. 3. Directionality. The most distinguished property of laser light is its directionality. The emission of this source is confined in a collimated, almost parallel beam of very small divergence. 4. Brightness. Laser is a bright light source and has high light intensity. Brightness is a quantity that depends not only on the total power emitted by the light source but also on its collimation. Laser hazards. In general, laser hazards can be classified into 4 categories. I. Radioactive hazards. I. Several exposure to laser beams resulting in partial or total loss of vision. The energy of the highly collimated beam might burn cornea, or if it could pass through the aqueous media, it will be concentrated on the retina. The lens of the eye focuses the laser beam on a very tiny spot of concentrated energy at retina. Skin. The skin is much less sensitive to laser radiation than the eye. The amount of reflected, absorbed, and transmitted radiation depends on the laser wavelength and the pigment on the tissue. Exposed to high-power radiation causes reddening in the skin and may cause damage to the organ beneath the skin. B. Toxic hazards. Toxic hazard result from rapid heating and vaporization of targets as they expose to high-power laser beams. C. Electrical hazards. The input power for the laser systems is electrical and high-voltage power supplies are required and sometimes involve large capacitor. Electrical hazards involve shocks depend on the current flowing through the body. This depend on the skin condition moist-dry. The physiological effects of current flow in the body vary from mild sensation to painful for low currents and to muscular paralysis for high currents. D. Explosive hazards. Explosions occur in flash lamps and capacitors, for example the flash lamps used to solid-state lasers. Laser categories. The majority of lasers in use today fall in four categories. These are solid-state laser, which includes Nd:YAG laser, and ruby laser. Gas laser, which includes Hien laser, argon ion laser, and CO2 laser. Liquid laser, which include the dye laser. Semiconductor laser. The medical applications of laser. 1. Nd:YAG laser is an excellent tool for tissue coagulation, so it used in the treatment of hemorrhagia uncontrolled bleeding from uterus. It is also used in ophthalmology for a diagnosis and treatment. 2. AR+ laser is used in the treatment of diabetic retinopathy generated heat to photocoagulate the retina. It is also used in dermatology and plastic surgery. 3. CO2 laser is used in cutting and coagulation. It is also used in neurosurgery, plastic surgery and ophthalmology. 4. Dye laser is used for cancer tumor detection and treatment. It is also used to fragment gallstones and kidney stones. 5. Laser reduced the blood loss during surgery. Bloodless knife. 6. Laser reduced edema and postoperative pain. 7. Laser used for skin beauty and teeth whitening. 8. Laser carries detection. 8. 9. Laser used for special three-dimensional images called holography.